What's going on, guys? Drew Riley here with AR Custom Knives, and I recently designed and built my own 2x72 belt grinder, and I just wanted to make a series of videos showcasing the various features and functions that I built into this machine and that were important to me as a knife maker. So this first video will be more of a general introduction or overview. It'll be probably mostly me talking, and then maybe towards the middle or the end of it, I'll go ahead and take the camera and try to show you a little more closely some of the features that I'm discussing. And then in subsequent videos, I'll show you some physical setups, maybe some grinding on the machine, and just the different ways that this machine is quite a bit more versatile than I think what's maybe currently on the market today, and certainly more so than what I started making knives with, which was a no-weld grinder sander. And let me say, that is a very capable machine. It is a great starter machine, but after making knives for a few years, I really found myself wanting some more capabilities, some more versatility, and really wanted to upgrade to a better machine. And that's when I decided to sit down, start designing this one, and I was finally able to bring everything together, get it built, and really couldn't be happier with how it's turned out and just how well it's been working for me. So to get on with the video here, this is a 2x72 knife grinder or belt grinder, and that is more or less the knife making standard today. You can get just about any type of grit, any type of material or configuration of belt, including certain specialty belts in a 2x72 configuration that aren't as readily available in other lengths and options without getting them custom made or potentially paying a little bit more for those. So it was kind of a no-brainer for me to go ahead and build it in that configuration. Of course, it can be split down to 1x72 belts if needed. I would just have to get the applicable tool arms and platen set up for that. As far as the material, it is made from 6061 half-inch aluminum plate. Several benefits to that material. For one, it is a little bit more cost-effective than steel. It is easier to machine, it's lighter, and it's really a little bit more maintenance free, in my opinion, in that you really don't have to work or worry about keeping it from rust or oxidation, other than a few fasteners here and there that maybe need a spritz of oil or maybe some WD-40 from time to time. It's just a really great material to work with. The plate itself comes relatively flat, and again, it's just easy to machine. The cost is in a comfortable spot, and in my opinion, it's just a really great choice for machines like this. And although it may wear just a little bit quicker in certain areas than steel would, I've made several considerations for that, in that I've used threaded inserts, drill bushings, different bronze bushings and things like that. And I'll go over that more as I go throughout the videos. But suffice to say, there was a lot of thought and deliberation put into even the smallest design features of this machine. And I think hopefully that will come through as I kind of go through some of these things in the video. Now, one thing that was important to me, and one thing I was previously lacking in the shop, was that I really needed a horizontal capability on my grinding machines. And there is certainly something to be said about having dedicated machines, dedicated workspaces. You save a little bit on setup time and can jump from one machine to the next quite quickly. That said, there are still several benefits to having a cross-functional or multifunctional machine that can be switched from one to the other, and really not that much extra time. So after thinking about it long and hard of whether I wanted one machine, two machines, or even more, I did decide to make kind of an all-in-one unit. And the thought behind that is if I do want to have dedicated workspaces and dedicated machines in the future, I can probably just as easily, and for not really that much more money, just go ahead and build another one of these and just kind of keep them set up in their respective configurations, you know, the majority of the time, to have either a mostly horizontal or mostly vertical machine. And that'll then even give me the option to have 2 vertical machines, 2 horizontal machines going at the same time, depending on what the application or the process is. And I think you get just a little bit more versatility there. Now, the theory is that sometimes the more options you have, the less well they'll do at either of them. But I think in this particular instance, you're really not sacrificing anything in one way or the other. And of course, we'll get a little bit more into that in the different setups, probably in subsequent videos here. Now, this machine does have multiple tool arm slots, and that kind of seems to be the way a lot of machine makers are going these days. It used to be that really wasn't an option. You'd have just one tool slot and then maybe a work rest that was attached directly to the tool arm or to the frame itself. But over the years, it seems that makers have really found quite a bit of versatility in having more than one tool arm slot, not only to stick a secondary tool rest in or a work rest, but also to reposition tool arms. I can have pretty much an instant height change if I want it without really changing the tool arm configuration at all. I can just lower that arm down to the second, third, or fourth slot if I want to work a little bit lower, a little bit higher, get a different viewing angle on my work. But also I can easily set up a tool rest or a work rest arm in there. And there's even certain applications where you can put multiple rests or multiple tool arms in, although you may need a longer belt. It gives you just that much more versatility and options when it comes to different knife grinding setups, especially where efficiency is involved. So that was definitely a must-have for this grinder. Another thing I really wanted was a good tensioning system, as well as one that was very easy to change or to take off and add on belts. So I decided to borrow an idea from another maker. Mick Strider gets the credit for this one, although I've seen it on a couple other makers' grinders as well. But I decided to use an over center cam tensioning system, which is pretty much just a binary on-off system. It does use a 100-pound gas spring in this particular setup, although different springs can be swapped out quite easily if you want a little less tension or even a little more tension, not that you would ever need it. But I'll go ahead and show that more probably in a subsequent video as well. Now, one thing that, well, a couple of things I really wanted in this machine. One was versatility or options as far as setups. So one thing that was very important to me was, for one, I really didn't want anything interfering with something else, specifically handles. So I did leave a couple of options for each tool arm slot. Here you can see 2 threaded inserts, you know, front and back. That's pretty much the same for the first and the second. Down here you're a little bit more limited because of the structure and the pivot plates here. So there's only one option on this side. But there are 2 options for each slot on this side, and those are all steel threaded inserts with thread locker, and that was for wear considerations, being that this aluminum is a little bit softer than the steel threads on those handles. I did want something that was going to last as long as humanly possible. But it's also replaceable in certain circumstances if I were to somehow wear out those. As well, I don't need to build a whole new frame. I can just heat that up, take those inserts out, put a new one in, and be good as new. So plenty of positions and options there where the handles will not impede on each other, but where also I can have them on one side or the other for ergonomic considerations. Similarly to that, I did do something similar with the tracking arm, in that there's a threaded insert on this side if you want it on the left hand or the motor side, but there's also under here a threaded insert for the operator or the wheel side, the belt side, in case you would rather have it on the right hand side, especially in horizontal configuration. Some guys prefer to reach over the top of the belt rather than under the machine. So you do have that option. It simply requires a slightly longer threaded stud so that you can clear the wheel here. Same really goes for this over center cam handle. It's currently set up on the motor side or the left hand side, but the way I designed this machine, it can very easily be removed and swapped over to the right hand side. There may need to be a slight change in the location of the internal stop pin, which really is a little more than just drilling and tapping an additional hole in the handle, but it can be quite easily switched to the other side and used right-handed or belt side as well. And then finally, just to kind of wrap up this general overview, probably one of the most important features I wanted on this grinder was that it be primarily toolless. I didn't really want to have to search around for wrenches or drivers or anything like that in order to change something. You know, especially if it's something that's going to be changed quite often, such as angles of a platen, tool arms and tool tables, different things like that. So anywhere that I could, which was pretty much anywhere that it was needed, I decided to make it a toolless option where that would not be necessary for any kind of a change or swap out. So that's pretty much the general overview of the machine. It is a direct drive, it is variable speed, that was important as well. Several benefits to that over a belt and pulley system. Most probably know what they are, but it does reduce generally the amount of vibration you'll see in the machine. You also get a little bit more torque in that you're not adding the considerations of an additional drivetrain, belts, pulleys, more areas of friction, and you don't have belt slippage as well. So plenty of added benefits to that. And I think that's really pretty much it for the general, more or less verbal overview. You can see it is a pretty small footprint, especially compared to, for instance, the no-weld grinder. This would also be similar, although it's slightly bigger than maybe a KMG or another belt and pulley system. You have everything much more condensed. And really, as far as the actual bench space on the base there, it's really quite a small footprint. You can see a 6-inch crescent wrench laying next to it there, which granted you do have the VFD obviously, and then the motor and, you know, the back of the grinder itself to consider, but really it doesn't take up a whole lot more space than probably any other machine on the market, so that was kind of a nice added benefit. So again, that's pretty much it for the overview. The next videos will be a more physical representation of the machine, showing it in its different configurations. And then I'll make some additional videos going over the work rest system, which I really haven't shown in this video at all. So stay tuned for the next one. That'll be part 2. Thank you.